Okay, this is for Spartan 1114. We've been talking about the possibility of building a gas dryer out of Peltier devices. And basically, this is a fairly robust ramification. I don't intend to build one that's this big, actually, unless the price seems under $100. If I can do it under $100, I'm doing this. Basically, what we have here is a center core, which consists of two of these heat sinks that are cut down a little bit and sandwiched together. And on all four sides of this center module, or of this center heatsink, there are Peltier modules. Now the air can't just blast right through that heatsink. Inside of it will be baffles that are stuck down in between the cooling fins that cause the flow of air to do something like this here. Basically what we have here is a plexiglass plate that has two holes in it. One of the holes is going to be for draining during defrost cycles. One hole lets the gas in, and as you can see here, there's the other end plate, and that is pretty much one of the easiest ways I think that we can hold this whole thing together. Just the four bolts holding together two plexiglass plates. Now please disregard some of the errors of this drawing. I had to use QuickCAD, which is a 2D drawing software, and it's not very good at all. It's got a lot of problems with it. Every time I turn around, it's saying the program was shut down due to fatal error and all this. I'm constantly fatally killing the program somehow for some reason. So a lot of these little errors you see here and like in the background there, don't take that for being part of how it's going to actually be constructed. It's basically, I don't have the patience to sit down and draw this type of stuff with a 2D drawing software. So drawing in 3D with 2D software sucks, and I'm going to get to 3D as soon as I can. But anyway, back to this. I have a couple more photos. Or not photos, but drawings. Here is a larger view of the subject topic. This is the main core piece that I was telling you about. And as you can see on all four sides of it, the blue represents a Peltier module, or perhaps an array of Peltier modules. And these here are just the hot junction heat sinks. And this is what the center module alone looks like. With just I've got a picture of a Peltier on top of it because I neglected to delete it. I probably should have did that, but basically just two of those heat sinks sandwiched together, possibly ground smooth, maybe flattened a little bit. I don't know that we want a big old huge piece of aluminum in there. It's going to be hard to get that down to 1 to 2 degrees or so. And here is an exploded view to kind of give you a better understanding of what I'm getting at. I really hope you can see these drawings. I'm using a laptop computer here, so. And again, disregard any errors you may see in the drawings. It's basically just due to lack of patience and improper tools. One of the economy ramifications that I have is possibly just using two like such, and then simply using maybe 1/16 of an inch baffles. Maybe 1/8 inch would be best. Probably ought to go 1/8 inch. Bunch of little 1/8 inch baffles like such, and just two Peltier modules sandwiched together with a gap of an 1/8 inch, and then we can just let the gas flow through there. And from some of the footage I've seen, I think once some ice accumulated, once this thing cooled down, this distance that I have here may be long enough to freeze the gas, or freeze the water vapor out of the gas. And one of the reasons why I'm really interested in this project is because what I have here is an $8 desiccant charge, and it's one of those ones that uses these blue little pellets that turn pink when they're done. Now that feature is a fairly costly feature. It caused them to use a chemical that's less powerful. If they would have just stuffed this with potassium hydroxide or sodium hydroxide, the thing probably would have lasted 10 times longer, and it could have been recharged by drying it out with somehow. But anyway, I don't know how long this is going to last on a torch, but I'm going to do the testing. before I build anything on this, I'm going to do a cost analysis to see if there is an actual practical feasibility within the concept. Because if this thing goes pretty quick, which I think it will, it would definitely be a viable concept. And one of the reasons why I'm really interested in this is in the wintertime, we run air compressors to power our nail guns. And anyone who's ever worked with high pressure air and cold weather knows that ice is your enemy. And ice costs the construction industry thousands of dollars per company a year, because the whole crew is on standby while I'm running around with a flamethrower melting all the hoses and couplings. A device like this, working in 0-degree temperatures, is capable of achieving a 59-degree temperature difference as far as I know. So we could get some extreme temperatures out of this device in wintertime and freeze a lot of water out of the incoming compressor air. So whether or not this is good for a torch, as far as the economical feasibility is concerned, I don't really care so much about that anymore. I'm more interested in the fact of this thing's ability to run as a desiccant, electric desiccant charge for air compressors. I mean, desiccant charges in shops are pretty big, and Aussie 50 told me they only last like 2 months. I don't know how much that cost. But this thing right here, once you buy it, that's it. It's done. You ain't buying no more chemicals to dry your gas with. This thing does that. But I do understand heat sinks are expensive. The Peltier devices I looked at were like $40 for a 10-pack. A 10-pack would probably build this. This is real close to the actual size of the device, real close. So it's only a little tiny little thing I was thinking about. Maybe it should be longer. I had envisioned something perhaps about this long, but a little one, I don't know how good it is going to work, but I can definitely say if I build this, it's going to be one of the coolest damn things I've seen in a long time. I mean, it looks like it's going to be really neat. So I don't have the tools and the stuff to do this or the money right now, but when I get it, definitely going to be trying this out. I'm really interested to know what you think about this. If you decide to build one of these, man, definitely show me what happens. I'm very interested in this concept. Like I said, I could care less about it being used for a hydrogen torch. I'm not all that much of an HHO fan per se. I do have a lot of videos on it, but my interests are definitely in other places. So let me know what you think about this. I think I showed you all the drawings I wanted to hit you with. If you can't see these drawings, let me know. I don't know how I would be able to email you QuickCAD drawings, because without QuickCAD you cannot view them. And I cannot send you QuickCAD because of the whole 80 line thing. My hacker buddy might be able to change that. He told me there's something about 80 lines of code that, or the first 80 lines are empty. So you got to reprogram your DVD player to read past the first 80 lines to pick up the disc and record it. Supposedly that's how they stop you from recording disc, is they start at 80 lines into the CD. So anyway, hope you can see this. Anybody else who's got any comments on this, let me know. I think it'll work. I do understand that hydrogen gas, or hydroxy, HHO, whatever it's called, turns back into water when it's burnt. But it turns back into steam. It doesn't actually turn back into water. It turns into steam that's so hot and expanded by so much that it doesn't have an extreme effect on soldering. Welding, I have no intentions whatsoever of welding with HHO. I wouldn't even use it to cut with. It's worthless to cut with even. But soldering is great, and the drier the gas is, I'm finding, the better your solder joints are. So I'm going to post this and send it